Welcome to this explainer. Today, we're diving into what is, hands down, the most crucial engineering partnership in human history. We're talking about the electric motor and the electric generator. Now, you might not think about them every day, but these twin inventions are essentially the beating heart of our modern world. They're these invisible mirror machines, quietly working behind the scenes every single second of every single day just to keep our society running.
So to really wrap our heads around the stakes here, I want you to picture something for a second. Imagine a world completely stripped of electric motors and generators. What does that actually look like? Well, it's not just a world where things are, a little less convenient. It's a world where the fundamental gears of human progress grind to an absolute halt. Without these machines, our daily lives would be completely unrecognizable.
We're talking no refrigerators to keep our food fresh and no washing machines. Elevators? Gone. Which means modern skyscrapers are basically pointless. Electric cars? Factory robots building all our stuff? Not happening. Even the massive power stations that keep our lights on wouldn't exist. The big takeaway here is that modern civilization simply could not function without this incredible engineering duality.
All right, let's jump right into Section 1, the spark of discovery. To see how we got to this electrified modern world, we've got to rewind to the early 1800s. Back then, scientists knew about electricity, and they knew about magnetism, but they were absolutely convinced they were totally separate forces. They thought they had nothing to do with one another. But that all changed with one completely accidental, mind-blowing observation in 1820. A Danish scientist named Hans Christian Oersted was giving a lecture, and he happened to have an electric wire set up near a compass. He noticed that whenever the current flowed through the wire, the compass needle suddenly twitched. This serendipitous little moment was revolutionary. It definitively proved that electricity actually creates a magnetic field. And, as you can guess, the scientific community was absolutely stunned.
So once they realized electricity could produce magnetism, the natural next question was, well, what if it goes the other way? Could magnetism produce electricity? It's a brilliant pivot, right? And it sparked an absolute frenzy of experimentation across Europe. One of the most inspired minds to tackle this was a British scientist named Michael Faraday. What's crazy about Faraday is that he had very little formal education. He actually started out as a bookbinder's apprentice, but his curiosity was just off the charts.
And the evolution happened incredibly fast. We start with Oersted's spark in 1820. Literally a year later, in 1821, Faraday builds the world's first simple motor. It was this genius little setup where a wire hanging in a dish of mercury just kept spinning around a magnet when electrified, proving continuous mechanical motion was actually possible. Then, boom, 1831. Faraday invents the generator. By the 1830s, American inventor Thomas Davenport puts together one of the first practical DC motors and even uses it to run a tiny railway. Fast forward to 1888, and Nikola Tesla drops his revolutionary AC motor on the world.
Which brings us perfectly to Section 2, the mechanics of motion. Okay, so we know the history, but how do these things actually work? How do you take raw, invisible electricity and turn it into physical, spinning motion? It sounds like magic, but it is just pure, elegant physics. Every electric motor relies on one basic rule. A current-carrying wire inside a magnetic field is going to experience a force. So, step 1, you put a loop of wire between the north and south poles of a magnet and run current through it. Step 2, thanks to that magnetic field, one side of the wire gets pushed up and the exact opposite side gets pushed down. Step 3, those opposite forces create a continuous spin. Just like that, you've turned electricity into motion.
The tricky part, though, is keeping it spinning smoothly. Early DC motors used these mechanical switchers called commutators to manually reverse the current at just the right split second to keep the rotor going in the same direction. It worked, but it was a bit clunky. Enter Nikola Tesla with his alternating current, or AC, induction motor. In an AC motor, the current itself changes direction naturally dozens of times a second. This sets up a rotating magnetic field that literally just drags the rotor along with it. No clunky mechanical switches needed. It was simpler, way more reliable, and practically maintenance-free.
And here is something that absolutely blew my mind when I first learned it. Converting electricity into motion is unbelievably efficient. A lot of modern electric motors can convert over 90%, we're talking a massive 91%, of their electrical energy straight into mechanical motion. Only a tiny, tiny fraction is lost as heat. That sheer brute force efficiency is exactly why motors are the undisputed champions of powering our physical world.
Let's move on to Section 3, the generator revolution.
So we've covered motors, which turn electricity into motion. But remember Faraday's reverse question? Can moving magnets create electricity? Well, in 1831, he proved they absolutely could, with one of the most important experiments of all time. He took a magnet, shoved it through a coil of wire that was hooked up to a meter, and the needle jumped. This is called electromagnetic induction. It simply means that moving a magnetic field through a wire produces an electric current. You move the magnet, electrons move. You stop the magnet, the current stops. And the faster you move it, the more voltage you get. That single principle is quite literally the foundation of every power plant ever built in human history.
And the really brilliant part is this. Once you realize that all you have to do is spin a magnet inside a coil of wire, you can use literally anything to do the spinning. We use flowing water in massive hydroelectric dams. We use the wind in giant turbines. We use heat from coal, natural gas, nuclear, or geothermal to create steam that spins a turbine. Even those little bicycle dynamos that power a headlight use the spinning of your wheels to do the exact same thing. No matter what the energy source is, they're all just spinning a generator to give us power.
And that leads us right into Section 4, the perfect mirror image.
This right here is my absolute favorite part of this whole explainer, because this is where everything clicks. We've looked at the motor and we've looked at the generator, but the real secret of our modern world is the breathtaking duality of these two machines. Think about it. A motor takes electrical energy and turns it into mechanical motion. A generator takes mechanical motion and turns it back into electrical energy. So a generator is practically the exact opposite of a motor. In fact, if you hook up electricity to a motor, it spins. But if you take that exact same physical machine and you crank it by hand or by a turbine, it becomes a generator. It's the exact same machine, just playing different roles depending on what you feed into it.
If you want the ultimate real-world proof of this, look no further than regenerative braking. If you've ever driven a modern electric vehicle, you know that when you step on the gas, electricity from the battery spins the motor to push the car forward. But the magic happens when you let off the pedal to slow down. The car's forward momentum mechanically spins the motor, instantly turning it into a generator. It takes the physical motion of the car, turns it back into electricity, and recharges the battery, all while slowing you down. It's just an absolute stroke of genius.
Which brings us to our final section, a world powered by symmetry.
From the electric toothbrush in your bathroom, to factory automation, to the massive turbines powering entire cities, we are entirely dependent on this system. I love this quote from our source material because it totally nails it. They are mirror images of the same physical laws, quietly working behind the scenes every second of every day. From Oersted's accidental compass twitch, to Faraday's induction, to Tesla's AC motor. These 200-year-old discoveries changed human history for good. They beautifully complement each other, creating an infinite closed loop of energy and motion. So I'm going to leave you with this thought to chew on. As we transition away from fossil fuels, how will these 200-year-old invisible forces continue to shape the future of clean energy and transportation? Because one thing is for sure, the sheer efficiency of the electric motor and the flexibility of the generator are only going to become more vital to our survival. Thank you so much for hanging out with me for this explainer. If you enjoyed learning the story behind the invisible machines that run our world, don't forget to hit like and subscribe so you never miss another deep dive.